Okay, good evening. Tonight we will learn how to visualize the temporal data, even the spatial data. Okay, we can visualize two types of data. Can have a temporal data like time series data or related to time or etc. Not the mapping. If you have the grid data or like related to location, then we can plot the spatial map. Okay. So I already shared the data year passengers.csv file. This is monthly year passenger. You can use any data, but this is a machine learning data. You can use temperature, rainfall, whatever, any data. Then I want to take the data for 12 months in 1949 from this data. Have a look. We have a data from 1949 to 1960. Okay, and every year we have 12 months. Okay, 12 months. Every year we have 12 months. So from January to 12, I just want to take 12 rows. Okay, just for plotting purpose. Just run this code. Here I just took 1 to 12 row and whole column. Okay. Then we can plot the line chart, histogram, bar chart. Okay, scheme plot, area plot, pie chart. We can visualize the map, etc., etc. So I will show you how to do that in MATLAB. First, you can just use a plot. Okay, this is a built-in function in MATLAB. If you use a plot, you will get the line chart. But this is very simple line chart. Okay, you will get this simple line chart like we have a 12 month in the x-axis and y-axis year passenger. Now we can modify the figure. Okay, so first we want to change the color and then line style and the marker. Then we need to use the data first, then comma. Within single quotation, we can use the B for the blue, okay, for color, B for blue. And if it's black, then we should use the K, okay, R for red, G for green. Then what is the line style? We can use dash dash, okay. You can see in the here you can just search the plot, you will see the references. Okay, then what is the marker? We want to add a circle marker. Okay, and you see we change the line style, we change the marker, we change the color. Okay, this is very simple. Then we can also add the line width, we can change the line width and the marker size. The same code, we can use just line width. This is a built-in function within single quotation, then should be the number line width 2, then marker size is 12. Just run it and you'll see the change. Okay, so now we increase the marker size, even we increase the line width. Okay, so we modified a bit. Then how to add the X label, Y label, title, and legend. Okay, so for the X label, you can use the X label, and then within single quotation, you can use the parenthesis. Then parenthesis, within parenthesis, you can use a single quotation, and inside the single quotation, you can write anything. MATLAB will understand as a string, like month. You can use a capital letter or a small letter, whatever you write here, it will be as a string. Okay. Then Y label, then title, then the legend. Let's run and see. So we have added month in the X label. Then we use the Y label as number of year passenger. Then we add the legend, like this is the year passenger. Okay, we modified. Then we can also change the font size, like we can set the GCA. GCA means the get handled to current axis. So in set, then in parentheses, we can use GCA, get handled to current axis. Then we can use the built-in function, font size. Then you can give the font size 12, 10, 16, or whatever. You just run it and you will see the font size has increased. Okay, so we can change the font size. Now, if we want to change the x limit and y limit, have a look. We have the x limit is 0 to 12. It's like here, okay, from January to December. But we can handle the x limit. We can say the 0 to 13, then the data will be inside the box, okay. Then we have the y limit, like from 100 to 150, or we can give 160, whatever. So we can handle the x limit and y limit, okay. Even in the next code, I will show you how to change the name of the x-axis. Like we have a 1 to 12. That means 1 means the data for January, right? Then February, March, April, May, June, July, August, September till December. So how to add the string? Like here will be January, then February, March, April, like this. So how to add that? So I can show you the next code. Okay. So for x limit and y limit, we can use the built-in function xlim and ylim. Then within parentheses, we need to use the square bracket, like indexing operator in Python. Okay. So then we can give the number like 0 to 13 in x. Then y is 100 to 160. Okay. Just run it. Yeah. So we change 0 to 13. Now you can see the month in December inside the box. Okay. And we have changed 160, 100 to 160. Okay. We can change it. Now, what I said before, I can change the x ticks as January to December, instant 1 to 12. Okay. Then we can also add the secondary axis. Like I have two variables. I need to plot in a one map. Then y-axis left. We have a figure like this, a figure. Then we have a left and right. In a left, we can use one. We can plot the one variable. Then secondary axis like y-axis right. I can add another variable. So how to do that? First, this is a left axis. Okay, y left axis. Then if you want to add another variable in the y axis right, you should write this command. Okay, y axis right. That means we want to add another y axis, secondary axis in the right. Okay, then plot the. Here I use the data for 12 months in 1949. Then I also took 12-month data, but from 150 to next 1950. Okay, the same thing. Now I just add the legend because the first variable is 1949, right? I use the 2 years data. So first is 1949 and the second data is 1950. Then I have the x limit and y limit. Let's run and see the changes. So here in this y left axis, I use the 1949. You see the legend. This is the line 1949, this side. And see the color, another one. And this is the 9050. Okay, it's the same data, but here is different. Like I use this two different data. And can you see the changes in the x tick? Like we had 1 to 12, like 1, 2, 3, 4 till 12, right? Now we have added the x ticks as January, February, March, April, then till December. Hi guys, can you hear me? Hello? Shamma, can you hear me?
Yes, it can be heard. Hello, people.
Oh, okay. Like people are sleeping.
Yeah.
Okay, thank you. So you can add another, like say for example, in meteorology, if you have the temperature data and the rainfall data, right? Two data sets are different, isn't it? The unit is different, like temperature in degree centigrade and rainfall is in millimeters, isn't it? So if you want to compare, it's better to add another axis. Like in the y-axis left, you can show the temperature, and y-axis right, you can show the rainfall. So you can compare together. Okay, otherwise, not good. Anyway, then we can use a vertical bar chart. Especially for line chart, we use the time series data. We can show the change of something as a function of x, like as a function of time, right? In the line chart, we can see how change y, how change the variable y as a function of time, like temporal plot. We also often see the trend or time series data. For time series data, we use the line chart. Now, we use the vertical bar chart to compare, okay? Compare the data, even we can compare the groove. For comparison, we can use the bar chart, okay? For bar chart, you can just use the bar built-in function, the same way x level, y level, x limit, the same way. Just you can use the bar function, okay? Then you can plot the bar. Then you can compare, okay? You can compare the from January to December, okay? I can see the year passenger July and August was high, okay? Anyway, we can also add the horizontal. You can just use H. Yeah, we can use the horizontal. We can plot the horizontal bar chart. Okay, just use the H. H means the horizontal. By default, it's vertical bar chart. Okay. Then you can also plot the pie chart. For the pie chart, we often use for showing the percentage. Okay, like we have a whole component, then we separate as a segment. Like whole data will be 100%. Then from 100%, okay, this part is 25% or 30%, 50%, altogether will be 100%. Okay, so pie chart. Then you listen mark. Then we can use the color map as Z, or you can use other color map. So you can also plot the pie chart. Okay, you can change the color. Like everything is 100%, only 100%, but we separate as a segment. Okay, like from January to December. We can also plot the area map. We can use the built-in function area. We can use the area map to see, okay, to compare. Then we can also show the steam plot, like for the cross correlation. Yeah, we can also show by steam plot. Okay, that change. Then we want to plot the two-dimensional plot. Two-dimensional plot means like as a function of x and y, we can see the changes of z as a function of xy. In the real example, like if you want to see the change of rainfall is z, okay? Then x is longitude, y is latitude. So you have a rainfall over longitude and latitude and longitude, right? So you want to plot, you want to see the jet like rainfall or sea surface temperature or any data, but you have x and y. X and y means like for the spatial map we can have longitude and latitude. Okay, we can try with the real data. Like I use the precipitation data from TRIM, tropical rainfall measurement data. I already shared in the WeChat group. From in this file, as this is a netcdf file, we can use the NC-read. So NC-read means in a MATLAB, NC-read function is used to read the netcdf data. Then these are file name trim.nc, then comma, then the variable name. We know the variable name is PCP. We can show the, we can see the variable name. So PRC, I have three variables, like it's three-dimensional. We have a longitude, latitude, and time. Because in MATLAB, time dimension is the last dimension, but in NCL or Python, first dimension is time, then lat, then longitude. But in MATLAB, it's opposite, like longitude, latitude, and time. So be careful, X, Y, and Z. Okay. From there, I want to mean precipitation. I want to mean over latitude and longitude. So 3 means I want to mean over time dimension. Okay, because I want to plot over latitude and longitude. Okay, I want to see the change of z. That means the rainfall as a function of latitude and longitude. Okay, then from there I can access the lat, is lat, and then latitude. Okay, then as it will open as a one dimensional. Have a look, run it, and see. See, mean precipitation is two dimensional. Okay, 182 into 120, the latitude and longitude. But if you look at the latitude and longitude, is a one dimensional, so we can't plot. Okay, in MATLAB it opens like a matrix, but in NCL or Python, other software or programming language, they use the default format, right? But in MATLAB it opens as a matrix. Then we need to change the dimension, like from 1 to 2 dimension. We need to fix with this main variable. Okay, for this one, in MATLAB we can use mesh grid, like a mesh, like is a globe. Okay, like globe is a like mesh, then we have a grid data, grid, the whole globe is like grid, so you can make a mesh or like wave. Okay, so use the mesh grid function, then we can use a square bracket and let y and ln x. Okay, we know let y ln x, then mesh grid let ln. So if you run it, then you will see the let y, and now you can see ln x is two dimensional, is the same as 182 to 120. Then you can see the let y is the same dimension. Now we can plot. Okay, we can use a p color. Okay, this is like shaded pseudo color plot. We can make a shaded pseudo color plot. That's why we use a p color. Then it must be what I said. It should be x, y, and z. Okay, so what is the x? X is longitude, y is latitude. Okay, then z. What is the z? Rainfall. Okay, then we want to shade, like we have a different shading method, like interpret method shading. Then color map, you can use any color map, HSB or jet color, whatever you can add. Then see the color bar, we can also add. We also want to add color bar. Then y level, the color bar name is rainfall millimeters. Then x level, y level, x level is a longitude degree east, and y is a latitude degree north. Let's run and see. So you have plotted the rainfall data. This is the longitude, this is the latitude, but we can't see the shapefile, isn't it? We can see the shapefile. So how to add the shapefile, like global shapefile? There is no shapefile, but you can see, I can assume this is a Bay of Bengal Arabian Sea, whatever. But if we add the shapefile, then it will be clear where we are plotting our data. We can know the location, right? Okay, in next code, I will show you how to add the spatial, okay, the global shapefile. Anyway, we can also plot the three-dimensional data. Okay, we can plot a three-dimensional, like one function is peaks. Peaks is a return n by n matrix. It's useful for demonstrating mesh grids, then surface plot, p color, contour map, and so on. So if we run this n by n 5 peak, we can make like this plot. Okay, n by n three-dimensional plot, x, y, and z. Okay, you can use your own data. Then we can use a surface. We can also plot the surface plot like x, y, and z. Use the peak, make n by n data. Then we can use the surface function, surf. Then we need to provide the x data, y data, and z data. Like this, we can show the longitude, latitude, like latitude, longitude, and rainfall. Okay, like this. This is the surface. Okay, if you have the data, then we can plot it. and show three-dimensional there. We can also use the mesh. Then you need to provide the three x, y, and z, like a mesh or wave. Okay, like this we can plot. Then how to show the spatial map, or like how to add the spatial or shapefile. Like this is our global shapefile. Okay, this is a globe. So how to add this shapefile in our data? Okay, let's see how to show. We have the same data. I already talked about the PRC data. Now we can figure it. Then hold on. This is a P color. I already show how to add this P color. Then same way, I already talked about this codes, right? Now we need to add the special, like the global shapefile. Then we can load the cost. Then hold on. Then plot. We can plot the spatial map like longitude in the, when you add, these are built-in data in MATLAB coastal area. Okay, you have the shapefile coast. Then plot, you plot is there is a longitude, there is a latitude. Okay, long lat, then the color is black. Okay, then title rainfall during cyclone Cedar, x level degree like this x limit, y limit. So if you run it, we can, now we have added the coastal area, coastal line. Okay, we added the shapefile, we added the coastline. Now we can see this is a Bay of Bengal. Okay, we can see the latitude, longitude. Okay, by this way we can add our special global shapefile. Now instead of plotting one figure, we can make a subplot in MATLAB, like a panel plot in NCL. Okay, even we can use the subplot in Python. So subplot means want to plot, like in one page we can add many figures. So in that case we need to plot the how many rows of the subplot, then how many columns, then index. Index means the position. Like in a one page, if you use the four figures, if you want to add four figures, what will be the matrix, like what will be the position, like how many rows? 2 into 2, 2 rows or 2 column. And what is the position? 1, 2, 3, 4, right? And where do you want to add your plot? So this is like row, column, and index. So I have a 4. If you have the 4, then I can use a 2 row, 2 column, and the first figure is 1 position, second figure is 2 position, third position, and fourth position. Okay, you run it, then you can see yeah, instead of one figure we added 4 figures in a one subplot in one. Okay, now how to save this figure as a 300 dpi or 600 dpi for the journal high resolution? You go to the file, you can see the export setup. In there you can see the rendering, then the resolution dpi means dot per inch. Okay, we can 300 or 600, then apply to figure. Yeah, I change it, then export. You can save the MATLAB fig, like in the next time you don't need to run the code, you can just open this MATLAB figure file, then you can edit. Okay, and you see the okay plot, can add. Then you can also save in PNG, EF, or other format, SPG. There is many format. Okay, I want to save as a PNG file. Where I saved it? Oh, it's coming. Yeah, can you see the figure? So by this way you can save it. So this is a high resolution figure, 300 kilometers dpi. Okay, thank you so much. This is for tonight. Do you have any question? Shamma?
Hello, hello. Do you
Yeah.
have any question, Sandy? So, Mr. Jalal,
Yeah.
uh, will we continue or this is the final class?
This is a finish. This is the final class.
This is the final class. Okay. So let me say something on behalf of all the IMSA members and the students who have
Okay,
been
okay, okay.